Hello everyone, welcome to another stream. How are we all doing? Hey there Ransor, hey there Bassandro, how you guys? Yeah. So last stream on Thursday, we were adding support for printing from shaders. So we could print out, let's get into the code. So using HCC, we have a built-in printf function. We just have to implement it in the GPU abstraction. But the idea is we've got this logo where yeah, we've got this logo that we're rendering. Wait a minute. Do I have it? Do I have Excellent. Right. So see this logo here. So we got the ability to upload images and that to a GPU resource. So we can take a PNG file and upload it to the GPU, then actually render it on the screen. But we're now working on like reading stuff back from the GPU because it's kind of nice to have that. And the first thing we're starting with is printf, so we can print stuff from the shaders. So we're passing in this printf buffer, and it's a write-only 32. And we put this in, and then it made me crash the compiler. And it actually was a very simple fix, but I fixed it off stream, and we'll go into that in just 1 second. But yeah, effectively we're just testing out this guy, right? This hprintf to this print buffer. So I think we've got the buffer made, right, from last stream. We have the sync code working, I think, but we're not reading back. We're not actually mapping the buffer back into memory. No, sorry. I think we're mapping it, but we're not grabbing the pointer, reading over it, and processing the printf commands back, right? So we should see test color, then the color put out like that. So why was the compiler crashing? So the compiler was crashing because there was an error that it was coming across, and it was trying to print it out to the terminal, but it was the arguments were wrong. So I made a fix for that. And then, so the error we were getting is this one. Wait a minute. So hop to the terminal, give it a nice run. Wait a minute, just check must be. Right, we're good. Right, where is it? Scripts. Got it. Right, this is the error I was getting. So by default, the constants are limited to 32 bytes, but they can go up as high as the hardware supports. So in Vulkan, it's about 128 bytes. It can support, but we've done it lower because for some reasons. But yeah, so essentially we just want to up this to 64 bytes. So these are the constants that you upload to the shader. These are the push constants, all the root constants in other APIs. So when we create our... So this is our function that actually calls the 3 different things, right? This renders the background, this renders the triangle, and this renders the logo. So notice how we have these constants here. So these constants were limited to 32 bytes. So what we've done is we've added a new flag into HCC now where we can extend that up. And then now it will allow us to go higher. That's all I've done. So let's so we can now run this. We don't see any printing. Why don't we see any printing? Because I think what we did last stream is we have wait a minute, what am I looking for? GPU internal? Something like that. So hprintf buffer mapped memories. So I think we're getting these. We're just not printing them out, is all. So to learn Vulkan, awesome. You've decided to climb a mountain, sir. Hey there, Not So Red, how you doing? Oh. So I think what we're going to do here is at the end of the frame, we're doing GPU C? I think so. So when we submit a frame, I want to look at that mapped memory. Wait, it's before we submit, isn't it? Or is it while we're... It might be in the back end, you see. Awesome, good to hear. Yeah, I think we'll go into the Vulkans. So I think what we've got to do is we've got to say, so if we submit, we sort of like get the command buffer we're going to be using, and then we... Oh. Wait, no, it could be a frame, end of frame start. Yeah, no, we could do this out in the... Yeah, so after this one, it'll be safe to do it, because here, inside this guy, we're going to be waiting for the semaphore to say, wait until this command buffer we're about to write to is available for us to use, right? So when start is done, we'll be able to read back from the... We have to read back from the readback buffer and read all the print data back. Did an interview yesterday for an internship. Awesome. What type of internship is that? And how far away is it from where you are as well? Or is it remote? I know it's like 3 questions, but yes. Active frame index. So this is going to like paddle between 0 and 1. Remember? And then what we want to do is get the ggpu hprintf maps memories. So, right, Milton time. So, we have 2 hprintf buffers, right? 1 frame, the GPU is going to be writing to 1. And at the same time, the CPU is going to be reading back what happened the previous frame, and then displaying that into the actual terminal window. Right? We'll read over it, and we'll display it all. And then like when the CPU has submitted the next frame, it's going to then go up to this one and then read it and shoot this one out, while the GPU is going to clear this buffer and write over it again, right? Basically. It doesn't necessarily clear, it just resets the counter back to 0 and writes over the data. So we need to get back the active frame index. So this is our void pointer hprintf buffer memory. And if we now what's really great is that HCC comes with a really good interop layer, and we can give it, right? We can give it the hprintf buffer, and it will scan over all of that and basically do the formatted printing into the terminal. It's not the best implementation. I just threw it together because I just wanted to get something working. It's missing tons of features, but yeah, for now it will do, and it at least just allows us to get something out. So we should just be able to call this guy, and we should just be able to pass in this void pointer here. Void pointers are the thing, and then this should hopefully be printing out what is in that shader, which is test color and then a color, right? So let's see how good that is. All right. Include HCC interop C. We don't have that file defined anywhere. Since we're doing single compilation, I'm just going to include the C file. You know. Right, I don't see anything yet. This is not good. So the reason is I know why. We are not setting up the buffer with anything. And we'll go into how the hprintf buffer data format is, and it will make 100% sense. Let's just run this for visuals. There are some Java questions. I think I missed in a few questions, but I don't know that much about Java. Not remote, but it's not one. It's not that far, so I won't have a problem. Nice. Yeah, if you don't have to travel too far, it's good. Okay, so web dev company. I said before, there's no game or graphics jobs around me, so I have to enjoy web dev for a while. Yep. Yeah. You'll be in for a surprise about how bad the stack is and all the tools and everything. Oh my days. But yeah. I hope you find something that you can at least make some money and do, you know. And but yeah, I also hope you find a job that's more related to games or graphics in the future as well. Just keep doing that sort of stuff. Yeah, it's not necessarily about the stories. I mean, like, when you just use the technology and just like see how like crazy some of it is. Like, I remember doing some PHP, and they would require that your class that you sort of like extend from a base class has a function with a specific name concatenated with some other variable name that goes on the end. And that's how they did like event handling. It was basically string manipulation of the method name to, and I was thinking, like, where in the documentation do I find these magic names? Like, they're just, it was so weird. Like, it honestly, it's the most crazy thing ever. Like, there's some stuff you just find. I have like forgotten a load of it, which is good, but yeah. It adds to the stories. But yeah. Yeah, it is really tough right now. Like, inflation is really a real bugger. Yup. Doesn't really help as well with the whole here in the UK, like, we left the EU and we're still dealing with that. Just all the crap from it. Yeah, it's good to earn some monies. And also, like, you can be sitting down at a chair, or, you know, don't have to go work out in the rain like it is right now, raining, you know. be quite comfortable, hopefully. Right. So why doesn't it work? Here's why. How does the hprintf buffer? Well, what is the format of this thing, right? The first integer is the buffer is like the number of bytes that the GPU is written to, and the second integer, so these are 32-bit integers, right, is the capacity. So what we need to do is we need to write a shader which simply sets up this buffer because it purely lives on the GPU, right? So what we need to do is make another shader where we're just going to call it CS. So it'd be 1 by 1 by 1, right? We'll just call it like frame initialize. And this is just going to initialize all the buffers on the GPU. No need to initialize. And, you know, really need to make some of these constants so we can not have to pass them all up, I think. So we're going to pass in the hprintf buffer, and we're just going to initialize that guy, set it up. So what is the capacity? So we'll just say if system value dispatch, dispatch index. If this is not equal to 0, well, no, there is the flattened one, isn't there? Yeah, just give me anything. Local flat. You know what? Right, so I'm looking to do something like probably, so everything in the vector is equal to 0. Yeah, I might have to do EQS G. So G means generic, S just means the second argument is a scalar, right? So if they're all equals 0 and then you not it, then we just return early. Now the first thread, because it's going to launch like 64 threads or 32 threads or whatever. So then this one is just going to be the one that actually sets it up. So so BC hprintf buffer index 0, right? Now maybe there's a thing, a constant. Let's just find it. Right, here we go, capacity index. That makes it, you know, a bit more legible, easy to read. So we've got a constant somewhere in one of these header files. So I think it's GPU hprintf buffer cap. So now that we've set that, the printf is actually going to work in the shader, because what the shader does is it atomically increments the number at 0, and then if that size is bigger than the capacity, then it doesn't print anything. So that's the reason why I wasn't printing anything into that buffer. So if we can launch this thing, run some man, it sounds like a germ. Hey there, Gloris, how you doing? Greetings. I wasn't preferring for terrible documents, can't find the proper installation set for them. There's some frames that can't. Yeah. I'm guessing you filter specific pixels to enable the printf other than accumulated 4K. Yeah. That's right. Yeah, so, you know, what's great is C has if statements, so basically you do that. And if you don't do that, you'll fill up the buffer, right? But we're not going to make it we're not going to build it into the printing utility in any way, because people can just write it themselves, right? But yeah, so it's all good. Right, so we're just going to launch another shader, and it's going to be called frame initialize. We're going to set the hprintf buffer. Then we're also going to set this syncing is going to be will be fine. Frame initialize. We need to just launch one. Right, launch one group. All right, give that compile. This one is, because this gives us a Boolean vector back. So we need to say if all G not. There we go. So this one's saying this isn't declared. Unexpected open token. This can only be used when the left expression is an array or a buffer. Got a texture. Write only. Sorry, buffer. Uint32t. Oh, why isn't this cap available? Do we need like a shared header or something? Yeah, that'd be nice to share this information between the internals, I think. Should it be a constant? See if we pass these things in. You know, let's just hard code this for now. I just want to get something working, but I think there's a refactor due to for this thing. So where are we going? Let's just program to 8. Oh, what did you do? Expected int. I think it's my thing above. Expected int scalar or vector type as result type. Bitwise XOR. So that's when you do a not. Alright, interesting. Because if we take that not away, that'll work, yeah? Have a think about that. Linux kernel subsystems have the same issue sometimes. Right, I see. Oh wow, that sounds crazy. It must be really hard to work in a project like that because it's such a big project. It's huge. It's crazy how something like that keeps, you know. I've not looked into kernel the kernel development, but it does look, you know, seeing the number of lines that get committed each year or something is just insane. Yeah, so we've got a little bit of a bug in the compiler. We could probably fix this pretty quick, I reckon. So expected integer scalar or vector type as the result type of a bitwise XOR. But it's a Boolean, right? That's the problem. Bum, 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 bum. So there's an instruction specifically in SPIRV called logical not, I reckon. And it works specifically on the Boolean types, you know? Op logical not. So it means to be calling this guy. And then on the integers we call bitwise XOR with a -1, right? And then it will logical not. So yeah, that's the problem. So I just need to quickly go into the compiler and fix that. I don't know why it's not calling it, honestly. It feels weird. What does all-g do again? Does it always return a Boolean? Always returns a Boolean. Right, that's good to know. Okay. So let's just hop into the compiler project and let's get that fixed. So that'll be in SPIRV gen. Okay. So we're generating some SPIRVs. I could have swore we had a logical not going on, right? Oh, is any logical not equal? This feels weird. So where's the bitwise? Where's the bitwise XOR? Right, so it might come out from higher, from the abstract machine languages then. Do we have a... And I must have not had a Boolean before in this, right? This seems weird. So can I quickly jump to this op? So this is my own abstract machine language. It sits above... It's the same level of abstraction as SPIRV, but it's our own one. Our own IR, as you call it, right? It's a compiler assembly in a way. So do I have some form of logical... No, okay. What about a not? Right, there's nothing there. So I guess let's do the bit XOR -1, I reckon. So I think wherever this happens, it's just, right. So we go into the abstract machine language generation, wherever we generate this guy, right here, yeah? Is this it? No. Many not, no. Logical not, this is it. So it's just going to say, if the source type is not a Boolean, oh. Should that be equal? Should it be equal to Boolean here? Because if it's equal to Boolean, do convert to bool. And I guess this true here says flip it the other way. Right, so maybe there's a not equal. Yeah, flip the Boolean result. Yeah. So has this been... If I do that, does it fix it? I feel like I'm already doing that, you know? So I gave it a compile. I didn't break any of our current shaders, apparently. Well, they... Right, so can I go and grab the binary and chuck that into game van engine and see what happens. Oh no, not there. So if we go into here now, press F5. It works. There you go. Right, so I want to make a good build of that because I just made a slow version. Can we make a release version, please? I don't know how. I guess I lightly tested and fully test the logic. Maybe it was weird. Right, let's go and grab that binary. Now I got to remember to commit HCC as well, because I've done this before, I've forgotten about it. Excellent. So we've got the optimized ones, so now they're faster compile times. And let's get out of that project and back into making the game. Yeah, and also, have you seen that Rust? They've got Rust. You can use Rust in the to make kernel modules now. And are they bringing Rust into doing kernel development in general now? I'm honestly surprised Linus actually is given the go ahead on that stuff. You know, because Linus is typically like a very he's a very elite individual in a way, right? He's very strong in his opinions, and now he's just a bit he seems to just be quite, you know, just lets people do more things now. I reckon it doesn't get set off as much. Yeah, C isn't the problem with the kernel. Exactly. Show them. I do wonder if you can express the machine checkable constraints through other means of language. Just a second, as I could. Yeah, but that'd be a bit loosey, very loose, you know. If you have to check it through like a comment or something. But yeah, maybe with some machine learning, right? Yeah, laid back and understanding person, yeah. It's interesting how he's made that change. It's probably much better for the project in the long run, though. But I do miss those days. Yeah, a bit of Rust has made its way into the Linux kernel. I do appreciate why why there's just a misunderstanding just can wipe out the benefit of a new language might bring. Yep, all that interrupt code is a lot, isn't it? Yeah. Oh no, Windows on the Rust bandwagon too, isn't it? Yes, I remember hearing that actually. How do you get into this low-level stuff? You just start and keep, find a place. Let's, have you got anything you want to do specifically? I guess, is it operating systems you want to learn? This has a tough job. Kernel regression has impacts a lot of people. Yeah. Yeah. Right. So, does it work? Oh, well, it's printing zeros out into the terminal, and then it crashed and died. We've got segfault. Oh. We're grabbing the wrong buffer, I think. We're grabbing one while the GPU is writing to it. Guaranteed. Guaranteed. How do we know? What is our active frame index? No. It's probably fine. Yeah, something fishy is going on. Where's frame start at? Here we go. So we grab the active frame. You would have started, meaning you would wait for this one to be free. You'll get it, and then you'll print out. It seems fine. It's hard to tell. Should we pipe into less and see what happens? Yes, this doesn't really print out color, does it? We should see the word color there. Oh my days. Alright. Here's the other problem. We start the cursor writing over the constraints of the okay. So this initialize frame, right? The problem is when the printf goes off in the shader, it atomically adds to this cursor, which is at 0, yeah? So if the cursor starts off at 0, guess where it's going to write over? The cursor itself and the capacity of the buffer, which means it will cause problems, right? So what you need to do is you need to start it after these guys. Okay, so it starts on 2. That's the next problem. And there's the fix, printf working. There you go. Would you look at that? From the shader, we can see the values. So that's going to be super handy when we need to do some research and development, right? Being able to debug shaders as if it's like, you know, programming from the CPU is vital, because if not, you can maybe export a certain color and debug that way. But seeing the value is sometimes what you need. So this is good. So we've got that working now. So let's have a think. What I want to do next. So we still want to read back more things, right? I think it would be good if we can read back from a buffer and a texture, and also like how a CPU queues up a command buffer for the GPU to go and execute, right? It queues up a command buffer of dispatches and the GPU execute that. We should have something that goes the other way around. We should have the GPU allowed to queue up commands for the CPU to go and do for debugging purposes, but also maybe for non-debugging purposes. So you can think of the hprintf buffer as that already. It just queues up a bunch of printing commands, and it eventually gets filled up. So I think this is going to be, yeah, I think those are two things I want to do. And then after we've done those two things, I think I want to take a pass over how they've been implemented and really clean it up a little bit, because there's something to do with specifically around this thing here. We have to pass in the print buffer every time, And that's going to get annoying. And I think we want to be able to have that as some constant that we just use. And yeah. But we'll get into that when we get there. What is shader printf? Well, we've just printed values from a shader. How am I doing it? Hey, Sonic King, thank you for the raid. Appreciate it, my friend. Yeah, so basically, like, the way it works from a low level is we just have a buffer, and the first 4 bytes, so it's a buffer of 32-bit integers, and the first one is the cursor, where the cursor is, and the second one is the capacity of the buffer. And we set that up at the start of every frame on the GPU. And then what happens is every time we call this, so we have our own shader compiler, right, which compiles C to SPIR-V so we can use it in Vulkan, right? I want to port it to other graphics APIs in the future, but for now I just want to do a really good job in one, right? So we can call this hprintf macro, and essentially takes that capacity, pulls out the buffer, it works out how many words it's going to write to the buffer, atomically adds to that cursor index, right? This cursor here. So it took out the capacity, it adds to this count here, and essentially pre-allocates a range. Now, if this index is less than the capacity, we can go and actually print. If it's not, we will subtract that capacity from the from the cursor again. Sorry, subtract that word count from the cursor again. So another shader has a chance to maybe fill up the remainder of the buffer, if it can. And also avoid overflow problems. So if we get a success, we essentially print the string, the format string into the buffer. Here say, right, print that format string into the buffer, and then we go over all of the variable arguments and then print those into the buffer as well, right? And then when the GPU has finished its frame, the CPU visits this memory, and it just parses the information, right? It's got the count in here and the capacity, and it knows how to process this. And then it just prints that into the terminal. Well, we're working on reading back stuff from the GPU today. So printing is one of the things. How complicated is a C to SPIR-V compiler? Well, at first I was just programming a new shading language because I thought the shading languages were kind of old and they were very limiting, but I wanted to try and make it as close to C as possible, so I could share my CPU and GPU code. And then as I went on, I was like, it kind of just has to be, I kind of have to be compiling C to SPIR-V. So I wrote my own preprocessor, tokenizer, syntax tree, IR, abstract machine language, and we translate that into SPIR-V. SPIR-V itself, the format is really good. It's and there's tons of good tools around it. It took me in total around 1 year and 3 months to get a fully releasable alpha working completely in my spare time. And I streamed it all as well. Yeah. Like, I could have probably done it quicker if I wanted to do exactly a C compiler, but yeah, I didn't know that initially, but I had something working within like a few months, and I just progressively built up from there. The CPU checks the buffer every frame, but it just swaps the buffers around. So one frame the CPU is reading from that buffer, the other frame and on the same frame, the GPU is writing to the other buffer, and then simply when the CPU has pushed the next command buffer to the GPU, it swaps them around, and it reads, and the GPU reads from the one that was written to last frame, and the GPU overwrites the one that was read from last frame, so it swaps them around. Yeah, it's really cool. Like, it's good that I'm actually using it now. And this is the whole point. Well, one of the points of this project is, let's make something, really find the issues within, let's iron out the kinks. So, yeah, super cool. Like, this is a shading language which is designed for the modern day programming for on the GPUs, because the current mainstream ones are they've got lots of old stuff in it, and yeah, it's weird. Okay, so let's implement a new API. So we're going to go into. So we've got the upload API. We've tested this out, right? We can upload to a texture, so we can get stuff read from disk, send it up to the GPU on those GPU only buffers and textures, and that's super nice. But we kind of want something to go the other way. So let's focus on the first one, which would be a resource readback. Okay, so we have to say readback. You need a readback manual as well. So you'd be able to specifically say, I want to read back this portion of the buffer. Now, how do we want this to work? Because you can't get it, when you call that function, you can't get it there and then. You can get the previous frames one, but not this frame. You can get maybe we can give back a handle and you check it when it's available. So here's the thing as well. There's kind of two ways you can write the API. You can say, and also you can have both of these. They can both coexist. You can either give it the pointer you want it to write to, which means you have to pre-allocate the buffer and it writes out to that buffer when it's done, or you have to call it within a certain window and copy the memory out yourself manually. I think we'll implement the latter one first because that's the lower level one, and the other one can be implemented on top of that one. What about Tobey Maguire? Okay. How do you program a shader in C that can be translated to sphere V? How do I? So it has some limitations, right? There's no pointers. But a lot of the basically the way I roll with this is I just have a one file. It can compile multiple files, but I just have one file where I've just got like my shaders in it, my compute shaders, right, or functions. Like it can include any other functions really. Like we've got our own maths library and everything. Yeah, if you'd like to read more about it, I do have install the app. No, here's the repo. There are some samples in here. There's a sample application. So if you clone the repo or if you download the release package, there's a sample application in here that you can run, and there are some sample shaders here. There's like 6 of them. There's There's the very basic ones and also some advanced ones in a way in there. But yeah, so you'll be able to read that code and really see how it all can hook up. Yeah, honestly, if you have any questions or want to ask, like off the stream, there is a Discord, and you can come and there's a channel in there. Ask anything. But it's not just limited to that project. We talk about all sorts of things to do with game dev and everything and programming. So feel free to hop in there and ask some questions. So right. So if we could read back, we kind of want to get back. So you can maybe get back like a handle, and then yeah. So maybe get back like a handle. You might get back like a GPU read back handle or ID or whatever you're gonna call it. So what happens is you can then say like void star GPU readback. Like maybe just call it like readback like this. I don't know. These names are sounding pretty terrible right now, but let's just get the API together. So you pass in like a readback ID, and you'll probably get back some form of maybe size that comes out, like how big is this thing coming back, and maybe we can get some other information. Maybe we can get back the resource which you actually read from as well. Maybe that is useful, right? But maybe not. So I can imagine that. So this is like the low level API, and you have to call this readback in a very specific place, and the lifetime of this pointer is only available in that specific region that you call it in. So you can only call it while you're building the next frame on the CPU. So after you've called GPU frame start, you must call your readbacks before you call frame submit, and you must copy all the data out, because as soon as you submit it, the GPU could technically start at any time and start overwriting that data that you've read back from, right? So this is maybe the quickest way. But if you don't care about the like if you care about how this is copied to some memory which has a longer lifetime, you want to use this API. Whereas if you don't care about how it's copied, as long as it just lives longer, there'll be a simple API. And that one is probably going to be something like, so we don't get back. So instead, we give it the destination, right? And maybe we give a and maybe we give a capacity, and then we can do an assertion inside to make sure it's big enough, and maybe it returns a U64 to tell you if where's the U pointer? Destination size or capacity. So we can throw surgeons if we overflow that, right? That'd be really nice. And we give you back how much of that destination was actually used up. So you can maybe allocate one slab of memory and just sort of like sub-allocate from that with different readbacks, right? So, okay. So now we have the... Now I have the two different APIs. What do we name them to avoid them being less terrible? So this one is like, it might be like readback. Like you're querying some form of readback to happen. Yeah, I think this name is probably okay. Readback buffer, readback texture, and you get back a readback ID, and you say readback date, maybe. Now these ones might be like readback buffer and copy, or something like this. Now, the thing is you kind of want to know. Maybe you want a way to say. Maybe you want back some form of readback ID, or some other type maybe to say so you can query it. So one that's not compatible with this. Oh. Maybe we can give it a different name. Readback buffer copy manual copy. Now the thing is we've lost the ability to get back the size. But the size is passed into here, and then again you can always manually calculate it with these anyway. Or with just those dimensions anyway. So I guess it's not the end of the world. So I think that's fine. Okay, so I think this is a good API. We can implement this one now. So maybe we can put some comments quickly to just basically say, you know, oh wait, we need to say like, we need a boolean to say like GPU readback copy completed, or copy status or something like this, right? And then maybe you want to copy like just a readback status as well, like is it ready yet? Because you might pass it into some code. Yeah, but it's got to be called within a certain window, you know? Yeah, I don't think we need that. So I guess we're going to say like this one. All right, let's do two different APIs or different regions, I think, and we'll put the comment above. So say this one and that one. So this one is more like, you know, read back data from a buffer, from a resource. And you must manually copy the data from the readback buffer from the temporary. Okay. Read back from a resource by copying it, by copying from the resource to a temporary lived readback buffer on the GPU. While the next frame, read back the data from a resource by copying from a resource to the temporary live read buffer on the GPU. Nice. While the it's not the next frame, is it? It's kind of 2 frames ahead. It's really weird. Yeah, it's two frames ahead, but from the CPU's perspective, it's instead of the GPU's. You want to say like when the CPU is processing or is preparing 2 frames ahead, the frame when the CPU is preparing the frame from 2 frames, preparing a frame 2 frames after requesting. Maybe there's a better way to write this. It's like, so from the CPU's perspective, when you say, hey, read back this buffer for me, send it to the GPU, and then 2 frames later you get it back. Right? Because when you prepare the next frame, this GPU is executing the frame you sent up, right? So maybe it's like, so when I say like, when the CPU issues a readback or like requests a readback, it'll get its opportunity or get its chance to read back the data 2 frames after while preparing a new frame. Something like that. Read back data from a resource while by copying the resource to a temporary switch the first word right. Temporarily. There we go. Temporarily lived readback buffer on the GPU. When the CPU requests a readback, it will get its chance to read back the data 2 frames after while preparing a new frame. By calling GPU readback. Yeah. So we kind of want to mention in these docs essentially like using You know, we'll skip that bit there. That's good. I think that's good enough. Now this API, so this one is like, so we can say like built does not say like use this API when you want to control how the data is copied from the short or the temporarily lived readback buffer to a longer lifetime allocation, right? Yep. And then this one is just basically saying like, this is built on top of the GPU the other resource readback API, and does the copy, does a straight copy from the temporarily lived readback buffer to a memory range of your choice. So essentially the data will be triple, depending on how you look, it'll be triple buffered, right? It'll be copied from, let's just get Milton out again. So on the GPU, you're gonna have your buffer, right? You're gonna end up writing to that buffer on the GPU. And then at the end of the frame or whatever, we're gonna schedule, or when it, at the end of the frame, we're gonna say, hey, our readback buffer wants to read, we wanna read back this. Okay, so we're gonna read it back into here. So that's one copy, right? And then like a frame later from the CPU is going to read back this into a region of its choice, right? So it's double buffered, right? Whereas you might not want to do the copy, you might want to process the data, just process the data and just eat into the time it takes you to make a command buffer, right? So it just depends. Um, 2 seconds, hold on. Just got a text from my wife. Two moments. I'll be right back. Hey everyone. Yeah, so got some news. I gotta quickly shoot off to the hospital because my wife's having trouble breathing. So, yeah, we're gonna quickly pop to A&E and hopefully she gets some form of like asthma pump, and then I'll probably, if there's time, I'll probably be back. Like I hope it shouldn't be too long. But I don't know. Sometimes you wait like an hour just to get seen. So yeah, we'll see about that. She's just pregnant and having some different effects pop up. So yeah, which is a shame. So should be back to maybe resume and perhaps we can complete this today if there's time. Fingers crossed, but not to worry if not. So I'm quickly just gonna find someone to raid. But yeah, keep an eye out on the Discord. Or if you are following on Twitch, just it should pop up with a notification when I come back. Thank you so much. Thank you. Yeah, I'm sure. Yeah, sure you're fine. Just get an asthma pump hopefully, and it should help out. Yeah, she had problems breathing last night, and yeah, it was quite difficult. Thank you. But yeah, just right. Just quickly, I think it was in you to setting. But yes, thank you everyone. I'll it's kind of ended early, but yeah, it's cool. Hopefully we'll be back in maybe a couple of hours if there's time. Right. Thank you for coming. Really appreciate it. And yeah, apologies. Right. Catch you later.